Welcome to the course Separation Processes. A separation process is any process that takes an input containing more than one substance and produces output streams that are enriched in some of the original substances. Just as when you pick berries or mushrooms in the forest, the separation is typically not perfect. Some mushrooms still remain in the forest, and some forest residues, for example leaves and needles, can be found among the picked mushrooms. To take a more realistic example, wood contains cellulose, hemicellulose, lignin and some other stuff. Cellulose is good for making paper, but lignin makes paper brittle and sensitive to sunlight. Thus, when creating paper from wood, we want to separate the cellulose from the lignin. However, not all the cellulose in the wood will be found in the produced paper. Some will be found in other output streams. Furthermore, despite washing and bleaching of the paper pulp, some lignin will remain in the paper. So, why study separation processes? Because a good choice and design of separation processes can improve product quality, save money, reduce energy consumption, and reduce environmental impact. We often want our product to be free of byproducts and unreacted reactants. Ideally, we want to send the unreacted reactants back to the reactor and purify the byproducts, turning them into products we can use or sell. The course is divided into 6 themes. In the first theme, you should read about a range of separation processes and suggest which to use for 2 separation problems. The remaining 5 themes focus on different separation processes and how to make design calculations for them. Please watch the 5-minute course overview video for more general information about these themes. How is the course designed and how will you find info about the course? Our main channel of communication outside lectures, exercises, etc. is through Canvas, so please make sure you have set a Canvas up so you get notifications. We have collected the most critical information on a few key pages in Canvas. On the page Course Overview and Detailed Schedule, you find a course overview and all the deadlines and other important dates. You also find when you are expected to have read the different chapters and what exercises we recommend you to do. On the page Course Material, you find information on what course material to buy, as well as all other files and handouts you will need during the course. On the page All Videos, you find video versions of the lectures. The videos will come in handy both for flipped lectures and if you get sick during the course. There is also a page on course evaluation and course development for those interested. You will write reports during this course. To help you in that and support us teachers when we give feedback, there is a bilingual Canvas module on report writing. There is also a module on programming in Python. We hope you will find this to be a good and interesting course. We do need your input after the course in the CQ questionnaire, such that we can make improvements from year to year. But we also need your input during the course, for example, through formative evaluation or through your course representatives, such that we can make minor adaptations on the fly during the course. We use a range of different kinds of formative evaluation. For example, buzz groups, raising 0 to 5 fingers in the classroom to answer quick questions, lab quizzes, your hand-ins on compulsory tasks, and the feedback we give you, etc. We also use peerwise, but more on that in a few minutes. The 2 labs in this course are both held in the Chemical Engineering Apparatus Hall. To be accepted into the Apparatus Hall, you must pass the lab quiz at least 24 hours before your lab time slot starts. During the distillation lab, you work in small groups, answer all the questions and discuss the answers with the lab assistant. During the membrane filtration lab, you will be divided into 3 larger groups and you will carry out 1 of 3 tasks. The lab ends with a joint seminar where you present to and discuss with the other groups. If your participation during the lab is satisfactory, you don't need to write any lab report. There will be a lot of different groups and some group assessment during this course. You are divided into 4 different exercise groups, 1 through 4, which are then subdivided to create in total at least 8 lab groups, 1A, 1B, 2A, etc. The exact number of lab groups depend on the number of students in the course. For compulsory task CT2, CT3 and CT4, the lab groups are subdivided further into groups of 2 to 3 students. For CT2 and CT3, you hand in your written report in Canvas. For CT4, you show your results to a teacher. CT1 has its own groups that is totally unrelated to all other groups. You are divided into 12 different groups. Each group should hand in a PowerPoint presentation and give a presentation to other groups. We do, however, also assess you individually. In Peerwise, an educational web resource created by the University of Auckland in New Zealand, you can get bonus points to the exam by creating one theory question and answering or commenting multiple questions created by other students. In order to use Peerwise, you must first create an account in Peerwise, then you connect to the course ID we have specified in Canvas, identifying yourself with your Steel username in Peerwise. The main course material we will be using consists of 4 different parts: the course book, the department handbook, support for note-taking, and diagrams. The book Introduction to Transport Phenomena and Separation Processes covers all the theory in the course. Our department handbook contains data and equations you will be needing and is also needed on the exam. Note that no notes are allowed in your handbook. One year we had to report 5 students to the disciplinary board and 3 of them got suspended 6 weeks each for bringing a handbook with notes in it to the exam. What you are allowed to do is to use post-it notes or similar and write keywords on them, that is, words that exist on the page you placed it on, such that you can create a thumb register to find what you need more quickly. If you use an older version of the handbook, you are also allowed to bring an errata list, the version history, to the exam. Please note that there is a list of variables and an index towards the end of the handbook. Support for note-taking and the diagrams you will be needing are printed as a joint spiral booklet, but are also available as PDF files. Please note that you need printouts of the diagrams. Using a used version of support for note-taking is not recommended and will likely reduce your learning. During the course, we also make other material available: lab instructions, compulsory task instructions, suggested solutions to exercises, video versions of lectures, etc. Before we turn our attention to the first theme of the course, let us first list a few common barriers to learning in this course. The first problem is thinking that it is optional to read the course literature. The course literature has been designed for this specific course, and we will assume you read the compendium. In fact, parts of this course will become very difficult for you if you don't read, and if you haven't read, it will be very difficult for teachers to help you. The second problem is writing and thinking as students rather than professionals. To get the most out of your education, you should lean into the tasks given and try to pretend that you work as a consultant. You learn what you train to do, and if you don't train to write and think like a professional, you won't learn to write and think like a professional. The third problem is thinking that an equation tells you the order of cause and effect. For example, that what is on the left side of the equal sign is the effect, and what is on the right side is the cause. However, you can rewrite an equation in many different ways, and moving things from the left to the right does not influence the cause and effect link. Furthermore, correlation is not the same thing as causation. If you all decide to eat ice cream today, the outdoor weather will not become sunnier, but on sunny, warm days in Sweden, ice cream consumption is usually high. For more common problems, see the re-exam extras videos.